Let's talk about subnetting. Subnetting is when we have smaller networks within one default network. Why we need subnetting? First of all, last week I told you that because we have a less broadcast domain. Can you imagine if we have hundreds of computers in same network, right? In big network. And what's broadcast address? When computer sends broadcast message, it must get all devices, all hosts within network must get broadcast message. Okay, so to make smaller broadcast domain, we are making subnets. Also, subnetting. We need subnetting to conserve IP addresses, especially if we are network service provider, internet service providers, because public IP address costs money. When we order internet service, actually they are providing with public IP address. We are paying money for public IP address. Okay, so each public IP address costs money. To conserve public IP addresses, we need subnetting. Without subnetting technique, we could waste millions of IP addresses. Can you imagine? Because you cannot assign host IP address which is in one network range to another network. You cannot. So host addresses always must be in its own network range. And look now, if we check class A IP address, let me demonstrate how many possible addresses we are wasting. Look here in class A. We know that, let's say, 76.0.0.0. We know that the first octet indicates in which class is IP address. And we know that 255.0.0 and .0, we have subnet mask. And those three octets will indicate that those are in host portion. Now, what about network side, network portion? How many possible networks we can have in class A? When in the previous slides, when I demonstrated, when I explained, I told you that in class A, the range starts from 0 to 127. And again, IP addresses are decimal dotted notation, right? If we convert decimal dotted notation, decimal numbers into binary numbers, what we will have? In class A, we will have all 8-bit 0 to 0, 1, and 1, 1, 1, 5, 6, 7, 8. This most left significant bit always is constant 0. And those 7 remaining bits are variable. That's why in the formula, so those 7 bits are variable. This means that in the formula, we will have to the power of n to calculate network numbers. And how much would be here? Maximum. To the power of n that is 128. So this means that in class A, by default, we have 128 networks, and each network has huge number of host addresses. Look now here, how many bits we have in host portion. Those are decimal numbers. But if we translate those decimal numbers, we'll have 8 binary zeros, right? And we'll have 24 string of zeros in host portion. And if we calculate, if we use our formula to get the number of hosts, here's our formula. How many bits we have? 24, right? The power of 24 is 16,777,000 and something total host IP addresses. This means that each network address in class A will have 16,077,000 host IP addresses. But now, if your network is, if you have only 100 customers, 1,000 customers, you are assigning that first available network address, right, to that customers, and you are assigning only, you are using only, let's say 1,000 host addresses, but you are wasting almost 16,776,000 IP addresses. Because those host addresses you cannot assign, you cannot use in different network address, in different network range. You are wasting a lot of money, because I'll remind you, each network address costs money. How to conserve those addresses? We have different techniques. We have subnetting. We have VLSM, which stands for variable length subnet mask. And also network address translation helps us to translate private IP addresses, because we can have in local area network up to 1,024 host addresses, and those addresses are private addresses, and we can translate all those 1,024 hosts and use for them just one single public IP address. Okay? In this way, we are conserving a lot of IP addresses. But still, entire world is growing. Internet, everywhere we have internet. Even small kids, and this is normal life in our life. Each family has probably nowadays 3, 4, 5 computers at home. So, can you imagine what could be happened without network address translation, without private addresses, without subnetting? Okay, so we networkers, network engineers, we're trying to find a lot of different ways to conserve our valuable IP addresses. But now we used absolutely all kind of techniques. But again, the world is changing rapidly. We need more and more IP addresses. We have shortage now. We need more. That's why slowly we are switching from IP version 4 addresses to IP version 6 addressing. But still, in local area networks, we don't need IP version 6. What is working well, it's nonsense to change, right? Why to change if everything is working fine? Are you agree with me? Probably. Right? Yes. Yeah. So again, we are using, and this was class A, right? Now let's see in class B. I said first bit, leftmost significant bit always is constant. If you can translate back these binary numbers, you will have maximum 127 here, right? So from 0, and you will get decimal from 0 to 127, and this is binary notation. Translated these decimals to binary, right? And that's why these zeros constant, always constant. That's why we have only 128 network addresses in class A. Now let's see in class B. In class B, we'll have always IP addresses will start from 0, and second bit always, most significant bit in class B will be 1 and then 0. Those 1 and 0 permanently, constantly, always same. If you translate any class B IP address, first octet, if you translate, you always will always have most significant left two most significant bits. You will have always 1 and 0, and remaining 14 bits you will have variable bits. That's why to calculate network addresses in class B, total network addresses in class B, you will have following formula now. To the power of 14. Because we don't use those 2 bits. And how much can you calculate in your computer? Can you use calculator, please, and tell me the number? I know that, I don't know how much. Can you tell me?
16384.
16384. 16384. So this means that in class B, we can have 16,384 network addresses, and each network address in class B can have remaining, how many bits we have in host portion in class B? Here is the let me type here in class B. I'll type here class B. We have subnet mask 255, 255, the 255.0.0. We know that zeros indicate host portion. This means that in host portion, in class B, we have 16 zeros, right? So this is the formula to calculate total hosts. The power of 16 is 65,000. Who can calculate, please? I think 65,300 and 300. I don't remember. Can you tell me?
65,536.
536. 536. So this means that in class B, each network, we have total network addresses. We have 16,384, and each network address can have by default 65,536 host addresses. Still huge number, because if we have in our network, we took one of these network address, right? But in our company, let's say we have only 500 computers. Look how many host addresses we will waste. So 65,536 minus 500. We have in reserve 65,036 host addresses. Either our boss must extend the company, or we are wasting 65,000 host addresses. It's still not good. Now let's check class C. What happens in class C? In class C, we have, if we translate first octet from decimal notation into binary, we will have 1, 1, and 0. Those three most left significant 3 bits constantly always will be 1, 1, and 0. And those 3 bits are intact. And look here in class C, what we have: subnet mask 255, that 255, that 255, that 0, right? If we translate those 255s, we have 3 octets, right? Octet is 8. 3 times 8 is 24, but we have 3 constant bits here. That's why we minus 3 and we have 21. So this means that in class C, we can have total number of network addresses to the power of 21. Please, can you tell me how many addresses? Can you calculate?
1048576.
1048
576.
576. So in class C, we can have 1,048,576 total network addresses. And each network address can have how many bits we have in host portion? 8, right? So to calculate number of host addresses, total host addresses, we will have to the power of 8. This means that each network address in class C can have total number of hosts to the power of 8, 256. Okay? But now, question, if we had 300 computers in our local area network, then of course we cannot use class C. We have to use class B or class A. But if we take class B, look here, what happens? We need 300 computers, 300 host addresses, but yes, of course, we can use class B but still we are wasting 65,200 host IP addresses. And what to do now? One of the technique we can use is subnetting.